Okay, so our last example of determining functions, we actually have a real world example. So let's see what it is. It says the graph shows the relationship between the width of a sticker, so we have the width of a sticker, and the length of a sticker sold at an art store. And it asks, is the relationship represented by the graph a function? And then it says, explain why. Okay, so we'll tackle the first one first. But before we do that, let's go ahead and decide. So I want to do a little labeling here. So this is our x-axis. This is our y-axis. And we know that our x-axis is the independent variable, or it gives our input, represents our input. And then for our y, it's the dependent variable, which is our output. Okay, so we have those two things already identified, and we know exactly what our input is and what our output is. So when we look at a graph, the main thing, we're still looking at the same relationship, a one-to-one relationship, having one input for every one output, a one-to-one relationship. So when we're looking at a graph, we want to see at every x, or every x value, or every input value, we want to see, is there only one y, or corresponding y value, or corresponding output. So if we look at the first point, we have at 1.5, and we look up this, going up our y-axis, there's only 1 point. So that's a one-to-one relationship. And then we do the same thing for the second point. Then we have what? There's only 1 point at 2, or the input of 2. Then we go to 2.5, the input of 2.5. There's only 1 point, or 1 output for that value. And then we do the same thing for 3. There's only 1 point, or 1 output value. 3.5, the same thing. 4.5, the same thing. So there's only, for every input, there's only one output, or it's a one-to-one relationship. And therefore, it is a function. Okay, so it is a function. But I kind of want to throw a curve in there so you can be able to easily recognize if it's not a function. Okay, so if I look at this, then I want to, let me do this first. I want to back up. So let's go ahead and put this in a T-chart, and then that way we can verify not just by the picture, but also by a chart. So if we look at this one, my x is, look, 1.5. So I'll do 3 halves that way. Okay, and then I'll use a decimal for another one. So we have 3.5 on my y is 2. The next one I have for my x is 2, and my y is 3. And then I have 2.5, so I'm going to do 2, okay, 2.5, or 2.5. And then for my y, it's also, what is that, 3. And then for 3, for my x, then I have 4 for my y. And then for 3.5, I have 4 for my y. And the last one, I have 4 for my x, and looks like 5. Okay, so I have all of these points that I've identified in my T-chart. And so if I go back to the other example, I said that if we look at the x, or the input values, I want to see, are there any repeating x values? And there are no repeating x values. And so knowing right offhand, looking at the T-chart, also we confirm our first answer, which is that it is a function. So in the second part, it says explain why. Why is this a function? Because it has a one-to-one relationship. And what does that mean? That means that for each output, there is exactly one input. So that's the reason why it is a function. So just so you can see, I alluded to it just a minute ago, if there was an additional point, let's just say here at 3 for x. So if I actually had another point here, then that tells me, so I have more than one point at the same value or the same input. So I have one at 3, 2, and I have one at 3, 4. So that means I have a repeating input, and with a repeating input, that means that it is not a function. So that's it. So that's the way you can look at a graph and tell whether or not it is a function, or whether it is not a function. Excellent.